Okay, so the next question that we got on the menu today is how can we determine the wavelength of a wave, presumably of a wave, has to have a wavelength has to have a wave that it occupies. How do we calculate the wavelength of something given its energy? And the equation that we want to use is this. Energy is equal to H multiplied by F. So I know here it might look like it's a V. I think it might be possible that some people use like a V looking thing to represent frequency. I guess since I've seen that so many times, I can kind of understand it, but I would highly recommend that you use F to represent frequency instead of V, because F starts with the first letter of frequency is F, so that makes sense there. And it will not be confused with velocity or anything like that, because this, I don't even know if that's actually supposed to be a V or if it's just a Greek letter that looks like V. I could easily be confused for velocity, and we do not want that. I would recommend using F instead. But this is the equation that we're going to use. E is going to be the energy. H, this is Planck's constant, or Planck. It was named after Max Planck. He was a very famous scientist. I actually have a picture of him on my wall over there at the Slovene conference, one of the conference of some of the top tier physics back in the early 1900s. Yeah, so that's his constant that we're going to use. And here we have frequency. Okay, so this is the energy of a photon. Which is, and photons are kind of like waves, kind of like particles. That's a controversial statement to say that a photon is either a wave or a particle. It's kind of controversial. So is it a wave or a particle? Yes, that's what it is. It's got properties of both. And we know, well, we have frequency, but what we really want is our wavelength. And we know that with the universal wave equation, we have the velocity of the wave is equal to F times lambda. You can see why we don't necessarily want to use that V looking thing for frequency because of this equation, and it'd be quite confusing to have two V shaped things. If we want to solve for the frequency, it would just be V over lambda is equal to frequency. So we can sub that into here, and we'll have energy is equal to H V over lambda. And it's asking us, how do we calculate the wavelength given energy? So we're trying to isolate the wavelength here. So let's send it to the other side by we can multiply both sides by wavelength, divide both sides by energy. So the E is going downstairs on the right hand side, and the lambda is going upstairs on the left. The E and the lambda are really just switching positions like that. So we have H over V over E. Okay, now let's get some values. So in this case, H is equal to 6.626 times 10 to the negative 34, and that's just the constant of Planck's that we're using. V is the velocity of the wave. Equals V equals C in this case. And C is the speed of light, which is 3.00 times 10 to the power of 8 meters per second. And then once we have our energy, well, it doesn't specify what energy that we should use, but we can get like a more simple version of this. So we can get lambda is equal to 6.626 times 10 to the negative 34. Multiply that with 3 times 10 to the 8, and all of this divided by energy, so we can get a nice like 1 like a one number relationship for this. Okay, so setting that in our calculator, Planck's constant times the speed of light, 6.626 times 10 to the power of negative 34. Multiply that whole thing by 3 times 10 to the power 8, and we get lambda equals 1.9878 times 10 to the negative 25 over the energy, and that will give us the wavelength. So if you have an energy value, let's say your energy is 1 joule, your wavelength would be 1.9878 times 10 to the negative 25 meters. Okay, so yeah, this would be your equation given this, and HC over E, yep, that's exactly what it is, and here is just like H and C multiplied together, gotten as a single number. So if you're using this function a lot, it would be easier to use this. Okay, cool. The above solution is good. Might be better if the subbing in of H and C was shown. Yeah, cool.